Hey guys, we're going to do notes from, we're not going to do all of them, but just a little bit more notes so we will be ready in class to review. So in our water example, we assessed that the type 2 error was quite a bit more serious. Death, sickness, cancer, there's a big stakes there. So our notes show a type 1 error and a type 2 error are different. We think about this as a type 1 error as a false positive. So I tested positive that I was pregnant when in fact I wasn't. That's a mistake with the test. And then the other one would be a false negative. I tested that I wasn't pregnant. The pregnancy test said I was not pregnant, and I am pregnant. That's another mistake with the test. These other situations are when the test gets it right. So when would the test get it right? This would be a false positive. You tested positive for pregnancy, and you are pregnant. So the test got it right. You tested negative for the pregnancy, and you are, in fact, are not pregnant. The test got it right, okay? Let's use these ideas to answer these three questions here, all right? You may want to read through and come up with your own answers and then use this as an answer case. So go ahead and pause the video and unpause to check your work. Okay, welcome back. It says, Mr. Whalecox purchased a trick coin that is supposed to land heads up 75% of the time. Okay. So, that's interesting. One of his students volunteered to test the claim. The student flipped the coin 50 times. Okay, so that's our N, right? And the coin landed heads up only 35% of the time. So that's our X. So as we go to the calculator, because we're practicing this, what we want to do is hit the house, right? Turn it on. Hit A for calculate. Hit menu. Go to statistics. Scroll down to stat test and pick one proportion z-test, right? How did I know that? Well, we were asked to test the claim, right? It looks like we only have one proportion. None of this P1 minus P2, not two proportion type of thing happening, right? So when I go to that, it asks for a P naught, an X, an N, and an alternate hypothesis, okay? So what is our P naught? Well, you can think of it as a little knot right there. That would be 75. We're supposed to assume that they're not trying to rip us off. It should be 75% of the time. All right, and how many successes? We got 35 heads out of a total of 50 flips. Now, we need to grab the less than sign under our alternate hypothesis. So we believe we got a proportion that's less than the P naught, which is 0.75. So X here is 35 out of 50. This is how we type it in our calculators. Okay, and what do we end up getting? We got a p-value of 41. So we're not going to get into this. We're going to kind of assume, but again, I want to practice each time we practice. So we do not really have sufficient evidence to conclude that the coin is faulty. You see what I'm saying? We can't send it back. That's actually a pretty likely outcome. So what kind of outcome did we get? Well, P hat 35 over 50. Let's see how far off it was. 70. Okay, so you actually did get head 70% of the time, not 75, but that's gonna happen. That's like getting head 60% of the time. Even though a coin's supposed to give it 50, you can imagine you'd get head 60% of the time. Doesn't mean it's the coin's not performing like it's supposed to. So now let's think, what are the consequences and the settings when you get a type 1 versus a type 2 error? So a type 1 would be, thinking about this, that the coin does work as advertised. The coin works as advertised. Okay, well, what does it advertise? It does work at this 75%. But the student not in our instance, but let's imagine the student does find convincing evidence that the coin is not working. So they find evidence that P is less than 0.75. This would happen if you got a p-value less than alpha. So what would be the circumstances relating to the possibilities of creating a type 2 error? Well, a type 2 error would essentially say that it was a faulty coin, but you didn't detect it. The coin wasn't working as advertised. So it was less than 75. But for whatever reason, the student ended up taking a sample that didn't provide us that outcome to be detected. The student doesn't find convincing evidence that the coin is not working. Okay, so now let's take a look. Which type of error may result in Mr. Wilcox returning the coin and writing a negative review? Oops. You're going to return the coin if the student finds convincing evidence that the coin's not working. You have evidence that it's not working, so you're going to return it. Oops, but that was the mistake. So this would happen in the circumstance of a type 1 error. Right? Mr. Wilcox would return the coin because he was given evidence that it wasn't working, even though it was in fact working as advertised. You just happen to get an unlikely sample. All right, if the student were to use an alpha instead of an alpha of 0.5 instead of a 0.1, what would this make it more or less likely to reject the null hypothesis when the null hypothesis is in fact true? So to reject the null hypothesis when in fact the null hypothesis is true. So would this change the likelihood of a type 1 error? And the answer would be absolutely, right? We said today in our notes that the probability of a type 1 error is equal to alpha, whatever it is we're setting our test to. So if we set alpha as 0.05, the probability of a type 1 error is 0.05. If we change it, if we use this instead of that, so that makes it sound like we use this first. So this is your before you changed it. After you changed it, your probability of a type 1 error is now only 5% of the time. So after the change, so would this make it more or less likely to reject the null hypothesis? This would make it less likely. In fact, 5% less likely. Why? because by reducing alpha from 0.1 to 0.05. All right, nice work, guys. And we will do this activity when you return, and we'll practice some multiple choice to review for the test. See you next time, folks.